If this hot wire touches the ground wire, the circuit breaker instantly trips. If the hot wire touches the neutral, it also trips. But if we place a lamp between the hot and the neutral, it doesn't trip. When we turn on a light switch, the current flows along one of the two service hot conductors to the property, then down through the electrical meter, then through the main disconnect, and then into the main electrical panel where it connects to one of the hot bus bars. It travels down this bus bar to the circuit breaker, and then along the hot wire to the switch, and then to the light fitting. It then travels back along the neutral wire to the neutral bus bar, and then back to the main disconnect, then back through the meter and over to the transformer. The circuit is complete, so the light illuminates. Now, I have animated this using DC current as it's easier to visualize, but in reality, we're using alternating current which moves backwards and forwards like this. If we measure between the hot and the neutral, we should read around 120 volts. The resistance of the lamp limits the current flowing in the circuit, and so only a small current will flow. This is much less than the rating of the circuit breaker, so it will not trip. If the hot wire came into contact with the ground wire, there would be almost no resistance, so an extremely large current would instantly flow. This would exceed the limit of the circuit breaker, and it will automatically trip to protect the wiring in the circuit. But all the other circuits in the property should remain energized. The NEC defines a ground fault as an unintentional connection between an ungrounded conductor and a normally non-current carrying conductor, including enclosures, raceways, equipment, or earth. When the fault occurred, it allowed current to stray from the intended path and traveled along a normally non-current carrying conductor back to the source, in this case through the ground wire. This is therefore a ground fault, and it means we have a serious problem with our circuit. The NEC defines this as an effective ground fault current path because it's intentionally constructed for fault currents to return to source.